Greetings and salutations all. In this video, we're going to talk a little bit about Google Colaboratory, or Colab for short, and how it relates to a data science sandbox where we can run our Python, R, Bash, etc. kind of code. I should mention that at any point, if you want, you can use the table of contents here to jump to a specific part. So here, right, if we go ahead and press the Google Colab button, notice how we go one forward to the Google Colab slide. So just a very helpful part about this slide deck. Now, the objectives here, again, are largely trying to understand why we want to actually consider using Google Colab over our local computer. And the second part is, what kind of course workflow can we expect with Google Colab? So with that being said, let's get started and look a little bit into what Google Colab is all about. First and foremost, you probably have two common questions on your mind. And that is, do we have to use our own computer to do data science? And the answer to that is no. Use what? The second question sort of falls on a similar line. Is it possible to do data science on old computers? And the answer to this is yes. You don't need a state-of-the-art computer to do anything with data nowadays, but you should consider using Google Colab. So in a case like this, we really are saying that your ability to do data science can only be augmented by Google Colab for a few reasons. First, Google Colab already has its environment set up. In a separate video series, we went through the different steps required to actually set up a data science environment with Python. The other part about Google Colab compared to your local computer that's probably very important if you're looking into doing deep learning is Google Colab offers a free GPU for about 12 hours on the free plan. So that is significant as your local computer likely does not have a discrete GPU, which means that any kind of training that you do would require a significantly longer amount of time. Now, if we jump down a little bit more, we have the third part here, which is the files. So where your analysis files are going to be stored. So in the first part, that would mean that we're storing files in the cloud instead of storing files on your hard drive. So the cloud version basically allows you to back up content, whereas in the local sense, you're sort of having a single point of failure, and that is if your local hard drive goes, so too does all of your analysis, unless you're using GitHub or a cloud service provider like Dropbox, BoxSync, or something to sync your files. So going a little bit more, why Google Colab is nice is if we think about Python and just using Python directly in an interactive manner by typing Python in our terminal or command prompt, it sort of gives us access to the internals of a car, whereas Google Colab and Jupyter Notebooks overall, or Jupyter Labs, is sort of providing us with this nice dashboard interface. So largely, Google Colab is going to be preferred as it provides us with a nice sort of environment to do our work. That said, please make sure that you're using Google Colab. You can access Colab by going to colab.research.google.com. When you launch Google Colab for the first time, you're going to be prompted here with the File Explorer. You can click on any of your recent notebooks, or you can easily create a new notebook by pressing New Python 3 Notebook. Going a little bit more further, frequently you'll see these little buttons that say Open in Google Colab. What that means is if you click on that button or you click on that link, it'll automatically take you to Google Colab's website and it'll load the analysis notebook, which is really great because it allows you to immediately start exploring what the notebook contains. Now, the one downside of this is by clicking on this button, you're getting a temporary notebook, which means if you close out of your web browser window for whatever reason, if you've saved or if you've written anything inside of that notebook, those changes are going to be lost. So it's very important that you create a personal copy by going either to the File menu and then go down to Save a Copy in Drive, or when you do Command S or Control S, you select a Save a Copy in Drive option on the prompt that comes up. Going a little bit more forward, right, Google Colab allows us to very quickly obtain results by running code. So here we can click the play button, so Command Control Enter, and we immediately see executed code alongside of the results. So we know that the number of seconds in a given day is equal to 86,400. Now, going a little bit more forward, Google Colab does offer something that's a little bit nicer compared to your local Jupyter environment, and that is you can run a specific portion of the code inside of a code cell instead of running the entire code cell. So here you can see an example where we're just sort of running the selection. Going a little bit more forward, as of a few months ago, Google Colab now has a variable viewer, which means that you can see all of the variables inside of your global environment. You can know what the type is and what their value is, which is really, really great and useful. So here we can see the value associated with the seconds in a day variable that we created and ran 2 slides back. We do have to hover over the variable name for additional details if needed. The other part about Google Colab that sort of differs a bit from a Jupyter notebook environment is the fact that you can actually see the executed code history, which means that you can iterate inside of the notebook and you can see each iteration across time. So on the left-hand side, you're seeing the latest version. And then on the right-hand side, under that executions tab that has been opened, you can see we ran 2 different cells. You can see what time the cells were ran at. And you can see how we moved from our prototype graph that didn't have any kind of coloring. It didn't sort of have any magnitude in terms of the actual point. So overall, we generally made enough significant improvements between the 2 graph versions. If we go down a little bit more, one of the nice features that Google Colab also supports is this notion of autocomplete, where the entire purpose here is just to hit tab after you start typing out a few words to have your function or your variable complete. So here we can see in the first example fabs and then factorial, and you can sort of navigate by using the up and down arrows to select between the options, and when you're content with the option, just press tab to effectively have the function name or the variable name fully typed in for you. Going even further, very frequently we might want to be able to see the help documentation for a given file. To do that, we can use the question mark and then what the function name is, which will open a help panel on the far right-hand side of Google Colab. This help panel shows the function's documentation string or doc string, and the doc string consists here of the function name, the arguments it can take, alongside of description of what the function is geared to do. Once you're done, please do make sure that you close the help panel by pressing the X next to help. This will allow you to regain screen real estate. Now, when you want to add code or text cells into the notebook, that is, you want to add additional content, you can do it in a few different ways. First, you can hover over a cell in between 2 cells to pull up the plus code and plus text option. Or what you can do is you can use keyboard shortcuts, so Command Control plus M or plus B. So Command if you're on Mac, Control if you're on Windows. We'll create here a code cell underneath the previous one. Similarly, we can create a markdown cell by first creating a code cell and then converting it over into a markdown cell. So Command M and B will create that code cell on a Mac. Control M and B will create it on a Windows. And then we have to issue the second shortcut of Command M and then M again to convert it from a code cell into a markdown cell. And then we can write text or a prose describing what the analysis sort of entails. I should mention again, the Command Control M portion is basically a requirement for Google Colab. A lot of the shortcuts match one-to-one with what is present inside of Jupyter Notebooks and Jupyter Lab. That is, B will create a cell below it inside of command mode, and M will change between cell types. One of the other really useful features of Google Colab is the fact that you have access to a bunch of different cursor movements. So you can have a continuous multi-cursor that spans multiple lines, which makes it easier for cleaning up data. Another one is you can do a controlled multi-cursor, which means that you can select the different points where the cursor should be placed. And then lastly, you can do what's called a multi-phrase select, where you can select one phrase and then expand that one phrase selection across the entire document. So if you need to change in place a specific phrase, or you want to see where these phrases are, Google Colab provides a great highlighting feature for that. Going a little bit further, you also are able to interactively sort of navigate the data without using any kind of subset commands. So here we're able to sort of filter the data by specifying, a lower bound to column 2. So this gives us just the first or the second row inside of this 1, 3, 2, 4 table that you're seeing. And we are able to easily upload external pictures or link to external pictures. If you press the Insert Image button, you can select a local image, and what will happen is Google Colab will embed that image directly into the notebook. So on the far right-hand side, you can see you have the data and the being added as an encoding for image.png/png. So this is a great way to sort of include here like graphics that might sort of represent a diagram workflow, or a graphic to sort of show an example of what a piece of data might look like. So moving a little bit more forward, there is also the table of contents option. Table of contents will allow you to jump between the headers inside of the notebook. So here you can go ahead and open the table of contents by clicking on that 3 accordion style menu on the far left-hand side. If you close that table of contents, again, notice that you get a lot more space, which means that you're able to do a lot more work. Another portion of Google Colab is actually having files that are not part of your notebook. So files could be data, so .csvs, they could be readmes, or anything along those lines. All files are placed at /content, so you can access these files by going to the left-hand side, clicking on the Files menu. You can view or modify the files by clicking on the 3-dot drop-down. So you can download a file, rename it, delete the file, copy the path or the location to where the file is, or you can refresh the file itself if you've been making changes to it. However, there is a caveat to the file option that Google Colab offers, and that is, regardless of whether or not the notebook is on your Google Drive or it's been launched from GitHub, all of the files that you upload into this location are going to be considered temporary, which means that they'll disappear after you close out of this Google Colab session. So this is one of the downsides of using Google Colab, but there is a solution that you'll see in the next slide. Another portion here is you can, again, upload files directly into this temporary session that Google Colab assigns to you. However, once you close out of this session, even if your notebook is saved to your drive, these files will get deleted. So it's not necessarily preferable to upload files in this manner. Instead, you generally want to be placing your files on your Google Drive account, and then what you want to do is you want to sync your Google Drive into the Colab environment. And when you sync your drive into the Colab environment, this basically gives you persistent storage, which means that the files that you upload or include will be saved for all eternity or until you run out of storage on your Google Drive version. The final part here, again, throughout this entire presentation, you've seen a lot of different keyboard shortcuts. The reason for why keyboard shortcuts are being presented in this way is it can really speed up your workflow. It basically will greatly help you in terms of completing tasks at a much quicker rate if you can avoid moving your hands off the keyboard onto a mouse. So with that being said, there's one keyboard shortcut that sort of rules them all, and that keyboard shortcut is the Command Control MH. So that brings up a list of all other keyboard shortcuts. Now, this is really great because it sort of shows you how the developers envisioned their analysis software being used. So keyboard shortcuts are normally assigned to tasks that you have to frequently do and accomplish. So it's always a good rule of thumb to check these keyboard shortcuts before working with any piece of software. If you're not comfortable remembering shortcuts, you can access the command palette. The command palette sort of is an English way of determining an action that you can use. So here, if I wanted to add a code cell, I could say add code cell, press enter, and then the command palette would automatically convert that sort of query into the desired keyboard shortcut and action. Lastly, you can switch between night and day themes. So night here is the dark theme, and then day here is the light theme. By default, you've seen Colab only displayed in the light theme. It's a very nice feature. Finally, if you are, again, using Google Colab to train a neural network or doing any kind of deep learning projects, definitely make sure that you use a GPU or a TPU. So GPU is a graphical processing unit, TPU is a tensor processing unit, to actually have your training go a lot faster. If you're not, don't worry too much about it. You don't have to set this option. By default, you'll be using a CPU, or a central processor unit, which is what all laptops have in order to actually handle computation. If you're interested in knowing a little bit more about what kind of features Google Colab has been adding, Google Colab does make available a release notebook where you can see all of the changes across the different months and what packages have been updated from one version to the next. So in short, we sort of went through and discussed a lot about what is possible with Google Colab, and we emphasized how exactly you can add Python code, cells, execute them, and all of the different features that come through these executions. Thank you for watching. Hope to see you in the next video. Bye now.